Professor, my name is Colleen. My student number is 101418497. This is my assignment 3. As you can see, I have a bunch of images import library from Python packages. We have NumPy, PyOL, SkyB, SkyImage, Map, Matplotlib, Inline Request, and ByteOS, right? So as you can see here, I have requested the image from URL and then I loaded it. And then you can see this is like a sport car, Lamborghini. So I have so these code above here already print out and visualize the image of the code. I will jump to the part that we requested by the assignment to do. So these things have already defined is the function to trim out the value between 0 to 55 range. And this function is just like help me to visualize the image and load it easily. I define function to apply convol to the current to an image light detection. So I'm going to answer the part that I did. So based on the kernel represented on the image above, create kernel detect for the line using convolution, apply to the card image and plot the results. So here I have already put my code line 45 kernel np array. As you can see, this is like 3D array, right? So the top rows -1, -1, 2. So the top row value, the value reduce the importance of the pixel on the top left on the top middle position. The second at the top right corner, amplify the pixels in that region, making diagonal changes more pronounced. The middle rows is actually the center pixel too. Emphasize the meaning it will contribute significantly to the detected edge, and the value -1 on both sides balance out the surrounding intensities. This one, intensity around the image, right? The bottom rows is 2 and -1. The 2 on bottom corner reinforce detection. This one of the line moving from moving from the bottom left to the top to the top right. So this kernel emphasize optimize detect line that run from the bottom left to the top right 45-degree angle. It highlight diagonal transition where pixel intensity changes in this direction. And I have scaled it. I have stored the image here. You can see it 45-degree light detection. The image is still the same, but typically the color detection have been filtered out, right? So for the 135 kernel, so this one for kernel typically the same thing. This is also 2D array with the value I slicing here. So the top row is just like center. It's emphasize the part of the image, right? It's waken the top middle and the top right pixel contribution, and the middle row center just emphasize helping maintain balance in diagonal light detection, and the bottom the value reduce the interference from other region. It's also reinforced detection of light running from the top left, from the top left to the bottom right. So top left to the bottom right. Typically this one is highlight moving diagonally from the top to the left bottom right about like 135-degree angle, right? It is particularly in detecting standard structure in image such as diagonal edges in object. So this is the image. As you can see here, it's pretty much the same above, but this one is 135-degree angle, 35-degree light detection, right? For section 2, this is edge kernel 1, right? So edge kernel 1 is to define 2D array. The function nb array to determine 2D array, so to represent a kernel in NumPy array. So the purpose in this case is to the kernel 1 is to design the detect horizontal edges. It will be applied to each pixel during the image convolution operation. As you can see, this is also 3D arrays as well. So here, down below here that I have added the trans h1 with the conv 2D kernel function. So this function call which applied the convolution operation using the edge kernel 1 to the image. So I have two parameter here, input image and kernel and edge kernel 1, right? The input image is a 2D numpy array representing the image, right? The function convol 2D take the image to the array and the kernel. It perform convolution detect feature. In this case, edges in the image, as you can see here, and the result will store in the trans. So typically the result of the variable is stored into the trans h1, right? So I show you the image here. For the part 2b, for part 2b, so this the same thing once again. This defined 2D number array representing the edge kernel 2. So it used to detect edges by computing the second derivative of an image, right? The purpose of this filter is to detect area where there's rapid changes in intensity, right? Like it's just like a simple edge detection operator that is sensitive to change in pixels, right? So I have also put the code here. So this one is applied to so there is a kernel called Laplacian's kernel, right? The edge kernel 2, as you can see here. It's actually input the image array, input image array here. Um, it's just typically and then I also display the image. If you compare to this one and this one, it's pretty much the same thing, except one is darker, like more black, more visual light. If you look at the bottom light of the first image here, and this one is a little bit like not too much visual, like it's a little bit dark out at the bottom, and on the top as well. You see the roof, it's the line is kind of it's kind of dark there. But if you look at the second edge detection kernel 2, you can see the bottom is more visualized also on the rooftop of the car too, right? So typically the resulting image will show the edge of the object in the image, right? So it's highlight the area where the intensity changed rapidly, right? So for the kernel 3, it's this one typically also the same thing. 3D array using NP array, 2D array, right? This is another form of edge detection kernel, commonly is known as Sobel operator or symbol edge detection. So if you compare the last one to the three above, you can see this one is more highlight, right? The intensity of these edges is more highlight, right? Like I mean, it's display the image in the kernel. It highlight the edge in the image more than the last two kernel, right? For the part B, I will answer those questions down over here a little bit. Did the network present sign of overfitting? If so, in which epoch? So yes, the network showed a sign of overfitting. The training accuracy increased steadily, but the validation accuracy plateau and even decreased after reaching a peak. This indicating that model is fitting well to the training data, but it's unstable to generalize to the validation data. Like overfitting is observed around epoch 5 as the validation accuracy did not improve further despite improvement in training accuracy, right? So how many layers this model have? So they're typically 5 layer, right? Convo 2D, max pooling layer, flatter layer, dense layer, and dense layer, right? No, only 5. Convo 2D, max pooling, flatter layer, dense and dense layer, right? The last dense layer, the one with 128 neuron and Rolo activation, the last one is 10 neuron and for 10 cholestome activation, right? For the Convo 2D, I have 32 filter, kernel size 3 is 3. That means 3 row and 3 column, ReLU activation, and same padding, right? Max pooling 2D layers, well, max pooling layer with 2 pool of size 2 and 2, column 2 and row 2. So explain what's the purpose of each the layer. So typically, to convol 2D layer extract feature from the input image using convolution. It detects pattern like edges, feature, textures, or color. Max pooling 2D reduce the spatial dimensions of the feature map. Down sampling, we have reduced computation and control overfitting. Flat layer convert 2D feature map into 1D vector, which can pass a fully detected layer. Dense layer fully collected to the layer that compute a weighted sum of input. It helps the network learn complex patterns. And last thing is the output layer, which is the final layer, the output probability distribution for each classes, right? So here I have at the mall layer, as you can see, the convo 2D. So for add one more called convolution layer to your model and run it again. So as you can see here, I have put my model here. I use KRS.layer, convo 2D, 32. So 32 is the number of filter or the feature maps, right? Output channel produced by this convolution layers. 3x3 is the size, right, of the filter. So the window size for convolution layer, right? Padding same, and so the padding the same. So this one ensure the output feature map has the same spatial dimension, height and width at the input. This is achieved by the image during the convolution, right? So the layer max pooling 2D, convo 2D, max pooling 2D, and flatten dense layer, right? So I use here is the kernel contract in good shape. So typically the activation, I don't actually put the activation. So that here the activation ReLU, it's actually it's actually helping learn more complex feature, right? Something like that. So the mag norm I put 3, so it applied the constraint to the kernel weight filter ensure that they do not exceed maximum norm of 3. So this can actually help in regularization and prevent overfitting of the image. So I run it again. I think it's gonna take a little bit of time. I already run this thing. Let me check again. Run all before. I can run all before. I think it's gonna take a little bit of time to run it, but that's okay. So let's move on to the model. Oh yeah, here it's also I put the max pooling 2Ds here, right? So the max pooling typically like a layer with the 2x2 filter that reduce the spatial dimension, height and width, right? I mean this one you can typically ignore it or you can add it. It doesn't actually impact any performance of this model here. So the flatten 2D array, the same thing, the dense layer. So I put 128 activation rule. So this one fully connect with the 128 neurons, and rule activation responsible for processing the learned feature and making predictions, right? Dense 10 layer, so softmax. So for this softmax, the output with layer 10 neuron, right? This one well typically the reason I use softmax because it ensure that the output value are in the range 1 to 1 and sum up to 1. So it typically have like representing class probability. right? So the model, combine the model, it's gonna take, oh, I have so this is the model. So the optimizer atom, the loss carrier. So we typically know all about the model, right? So I'm not going to explain it because it's gonna take a lot of time. So the ePod, finish ePod. So there's 25 ePod. So the accuracy ranges as it's going upward. It's going to increase the accuracy of the training and the validation from 0.4 and down deeper until 0.9 and 0.7, which is approximately 20%, which is good. And the result plotting as well. So compare the result between the ordinal model made using Keras. So the bigger model with the extra convoluted 2D layers with maximum 2D layers improve the feature extraction process. So the model may achieve slightly higher accuracy due to better feature extraction and produce overfitting. Right? Convolutional and a pooling layer allow the network to capture more complex pattern and downsample data progressive, while the all original model showed acceptable accuracy. So which means this one, uh, as as we increase more ePod, the accuracy in the training validation will also improve from 0.4 and 0.5 to 0.9, 0.7, which is around 90 and 70%. It's good. At the triple layer, run the comparison. So I have already also put it here. So this one is typically the same thing, almost the same thing, except the convolutor I put 64 and I put travel 0.5, right, which is the rate of 50%, and then is 10%. I am not sure why it's not running. I think it takes a lot of time. Uh, excuse me for that. For question 9, so a trouble layer is a regularization technique used to prevent overfitting in a neural network during training. The trouble layer randomly drop and deactivate the fraction of the neuron in the layer, right? As you can see here, meaning that each training example is processed by a different subset of neuron, and this help make the model more robust, and as it forces the network to rely on different combinations of neuron and prevent from memorizing the training data, right? Like for example, 50% drop, I mean half a neuron are dropped. Drop out typically applying fully connected layer. The rate parameter determine the percent of neuron that are dropped. So typically, thank you for watching my assignment. Excuse me for the runtime. I am not sure why it's not running. I think it takes a lot of time. So you can actually put it in and run it for your own. Thank you for watching my video.